By definition, a sequence, or also known as progression, is a list of objects, events, or numbers in a definite order of occurrence. So we have member of a sequence, and each member of a sequence is called a term. A sequence is said to be finite if it contains finite number of terms. An infinite sequence is one having infinite number of terms, thus the last term is not indicated. Then the notation A sub n represents the nth term or the general term of the sequence. Okay, so here are some examples of sequence. We have the sequence 2, 4, 6, 8. Then we have also 1, 5, 9, 13, 17, 21. Then we have also 1, 3, 9, 27, and so on. Okay, so for each sequence here, 2, 4, 6, 8 is known as a finite sequence because it contains finite number of terms. So there are only 4 terms. And letters B and C are examples of infinite sequence because the last term here is not indicated. Okay? Then there are 3 types of sequence. The first one we're going to discuss is arithmetic sequence. And by definition, an arithmetic sequence is a sequence in which the difference between 2 successive terms is constant. This difference, denoted by T, is called the common difference. Okay, for any arithmetic sequence in which A sub n is the general term, A1 is the first term, and n is a positive integer, where it is also defined to be the number of terms, the formula for the nth term of an arithmetic sequence now is A sub n equals A1 plus 20n minus 1 times t. Okay? Then the first and last terms of the sequence are called arithmetic extremes. Then the terms in between are called arithmetic means. And in defining arithmetic mean between A sub n minus 1 and A sub n, it is defined to be A sub n minus 1 plus A sub n over 2. And then if we have arithmetic mean of n terms, so the formula is A sub n plus A sub n minus 1 up to A sub 2 plus A sub 1 all over n. So now for arithmetic sequence, we're going to find the 6th term, 11th term, and nth term of the arithmetic sequence. We have the first one, negative 8, negative 5, negative 2, and so on. Okay, so to find the 6th term, 11th term, and nth term of this arithmetic sequence, we will start by defining the common difference of these successive terms in the sequence. So you can find it by having the second term, negative 5, minus the first term, so that is now plus 8. Why? Because it's negative 5 minus negative 8, okay? And the answer is equal to 3. So let us also take the other sequence, the difference of the other sequence. So where we have now negative 2 minus negative 5, we have it as negative 2 plus 5 is also equal to 3. Okay? So you need to do this finding first the common difference. The know if it is an arithmetic sequence. Okay? Because an arithmetic sequence is characterized by a constant difference. And you should take 2 pairs of successive terms in the given sequence. Okay? What I mean is take 2 differences of 2 successive terms in the arithmetic sequence. So as you can see, we have here the same value for your difference of the terms in the sequence. Okay? And since we have already found the common difference, so let us now define the 6th term. The 6th term is denoted by A sub 6. Okay? And we'll make use of the formula an equals a1 plus 20n minus 1 times t. Okay? So defining now the sixth term, let us replace n equals 6 now. So a1 is the first term, we have negative 8 plus n is equal to 6, because it's the sixth term, and minus 1 times t is equal to 3. So therefore a sub 6 now is negative 8 plus 6 minus 1 is 5 times 3. So we have here now negative 8 plus 15 equals positive 7. Okay? So that is now your sixth term. What about the 11th term? So for the 11th term, so we make use of the same formula, which is a sub n equals a1 plus 20n minus 1 times t. So this is now a11 equals a1, we make use of the first term, which is negative 8, then plus, and here now is 11. Okay? So that's now 11 minus 1 times t. We have common difference a while ago, which is 3. So therefore, a11 now is negative 8 plus 11 minus 1 is 10 times 3, that's 30. So what is now a11? A11 will give you now 20. Okay? And defining now the nth term of the arithmetic sequence, meaning the formula for the nth term of the arithmetic sequence. So let us make use of the formula now. A sub n equals a1 plus 20n minus 1 times t. Okay? So that's an now equals a1 is of course negative 8 plus 20n minus 1 times t, and equals 3. Okay? And with that, we can also see that then term now, or the formula for the n term is negative 8 plus 3n minus 3, or what is the a sub n is negative 11 plus 3 sub n. Okay? So this is now the one for final answer a sub n, then this is the 11th term, 22, and then this is the 6th term, 7. Okay? Second example here, we are still to define the 6th term, the 11th term, and the nth term of the sequence. We have the sequence a minus 3, a plus 1, then a plus 5, and so on. So let's start by defining a sub 6. So let us identify first the formula that we're going to make use is of course a sub n equals a1 plus 20n minus 1 times t. So let us take first the common difference of this sequence. So we have the formula for the common difference is a sub 2. What's your a sub 2? It's a plus 1 minus b sub 1. It's the first term, which is a minus 3. So getting now the common difference, so that is a minus 3 will be 0, then 1 minus negative 3. That will be positive 4. Okay? Let us take another difference of two successive terms. That is now a plus 5, which is the third term, minus the second term, a minus 1. So in defining now the difference, we have a minus 3 second 0, then 5. So it should be plus 1. So 5 minus 1 is now equal to 4. Okay? So as you can see, we have a common difference, which is 4. So we can now readily solve for a sub 6 using the formula. A1 is a minus 3 plus n is 6, because we are to find the 6th term, right? Then minus 1 times t equals 4. Okay? So what's that a sub 6? It is a minus 3 plus 5 times 4 is 20. So therefore, a sub 6 now is equal to a plus 70. Okay? So, what's next? Let us now define A11. For us to define A11, so we have the formula again, minus 1 times b. So we have already found value for the common difference b. You can identify a1. So that we can now identify now the 11th term. Of course, n equals 11 here. So using the formula, so I mentioned, so a1 is a minus 3, then plus n is 11 minus 1 times b, which is 4. And from here, a11 now is a minus 3 plus 40. For a11 now will be a plus 37. Okay? Then the last one now where we have a sub n, or the formula for the n term. So still using this formula a1 plus 20n minus 1 times b. So an now equals a1 is a minus bn plus quantity n minus 1 times 4. Okay? So where we have this now as, so a sub n now equals a plus 4n minus 7. Okay? So this is the formula for the n term of the given sequence. Okay? The 6 and 8 terms of an arithmetic sequence are negative 14 and negative 20. Find the 15th term. Okay, so to solve this, let us use this technique by identifying the terms now given. So we have the 6th term. So 1, 2, 3, 4, 5, 6. So the 6th term is negative 14. And a term is negative 20. Okay, then let us now find the 15th term. So we have already 8, 9, 10, 11, 12, 13, 14, 15. Okay, so specifically you are to find 815 here. So what is this 815? To find 815, let us utilize the given terms in the sequence, negative 14 and negative 20, and we can use them, these two terms, to find the common difference. Okay? So, let us have negative 14. Since we know that this is the 6th term, we can have this as a1. And since we have negative 20 is the 8th term, we can have this as your a sub n. And use the formula now, a sub n equals a1 plus 20n minus 1 times b. Okay? So we can now define d. So having now substitute out the values, we have negative 20 equals negative 14 plus, and here is how many terms we have? 1, 2, 3. Okay? So that is 3 minus 1, then times b. So it's now negative 20 equals negative 14 plus 3 minus 1 is 2 times b, so that is 2d. And then negative 20 plus 14 will give you 6, right? Negative 6. So what's then b? b equals negative 2. Okay? So let us now find the original a1 to find a15. So let us define the original a1 now to find the 15th term of the sequence. So how do we find a1 now? So use this formula, an equals a1 plus 20n minus 1 times d, and use the terms given negative 40 and negative 20. Okay, so your a and here will be still negative 20, and you have now a1 here plus how many terms do you have? So you count from a1 to a8. So how many terms? 1, 2, 3, 4, 5, 6, 7, 8. So that is 8 minus 1 times b. We have it as negative 3. Okay, so we have utilized the common difference negative 3. So that we have now negative 20 equals A1 plus 8 minus 1 is 7 times negative 3. Where we have now negative 20 equals A1 minus 21. And A1 now equals, you transpose negative 21 the other side, it's now positive 21. So you have here now 1. A1 is equal to 1. And then we can now define A15. So in defining now A15, so we'll make use of the formula again. An equals A1 plus 1En minus 1 times D. Where we have now An is A15, then A1, we have this a while ago 1 plus N is 15 because there are 15 terms given. So 15 minus 1 times D is negative 3. Okay? So what is then A15? A15 now is 1 plus you have 14 times negative 3. So what is now A15? So we have this as negative 42 plus 1 negative 41. Okay? So this is now your A15. So this is how we determine the 15th term of the sequence when you are just only given the 6 and 8 term of this sequence. As you can see, you need to find first the common difference D. Then after that, you need to define the original A1, which is the first term also. And then you can now define A15. So since we have already found values for A1 and common difference D. For N now, this is 15. Because we are to find the 15th term of this sequence given as negative 14 and negative 20 as its 6 and 8 terms respectively. Okay? Do you have any questions? This is another example. In the sequence where A5 or the 5th term is equal to negative 19, then A7 equals negative 29 or the 7th term is negative 29. Which term is negative 79? Okay? So, what do we mean when we say which term is negative 79? So, it means that we have N equals, N is the unknown here in this problem because we are to define which term is negative 79. Okay? So let us have that. A sub n equals negative 79. Okay? So particularly we are to find the term belonging to negative 79 or the term that belongs to negative 79. Okay? So with that, let us have now first is to identify the common difference. Okay? So let us again use this technique here. So this is A1, A2, A3, A4, A5. A5 is negative 19. Then your 7th term is negative 29. Okay? Let us make use of this given sequence to define common difference D. So initially, let us have this as A1. And of course, this will be your AN. So to get now the common difference, we have the formula AN equals A1 plus 20N minus 1 times D. Where AN equals negative 29, then A1 is negative 19 plus how many terms do we have? There are 3 terms considered. Okay? 3 minus 1, then that is now D. Okay? Then simplify now, we have this as negative 10 equals 3 minus 1 is 2D. And defining now your D or common difference, it is negative 5. Okay? That is dividing now both sides by 2 on your previous equation, which is negative 10 equals 2D. Okay? Then let us now define now the A1, here, okay? For the original first term. So you will consider the terms from A1 to A7, okay? So to get A1. So again, we'll make use of the formula AN equals A1 plus 20N minus 1 times D, where of course AN equals negative 29. Then A1 is unknown plus N will now be 1, 2, 3, 4, 5, 6, 7, right? So it is 7 minus 1 times D, which is negative 5. Okay? Then so negative 29 equals A1 plus, we have 7 minus 1 is 6 times negative 5. That will give you negative 30. Then let us transpose negative 30 on the other side. So what's then A1? A1 equals 1. And from here, we can now define N. That belongs to the term negative 79. So let us make use of the formula A sub N equals A1 plus 20N minus 1 times D. So of course, your AN now will now be negative 79. Then A1 is positive 1 plus N is a known part of the equation minus 1 times D. We have already found D a while ago, and that is negative 5. So it's now negative 79 equals 1, then minus 5N. Distribute negative 5N to your binomial N minus 1. So that's negative 5N plus 5. Okay? So this is now negative 80 minus 5. That will now be negative 85 plus negative 5N. And we're going to divide both sides by negative 5 with negative 5. So what do we get now for N? N now equals 70. Okay? So this is what we have for the given problem. Which term is negative 79? When we have the sequence A5 equals negative 19 and A7 equals negative 29. Okay? Okay, we have here the 6 and 8 terms of an arithmetic sequence are negative 14 and negative 20. Find the general term or n term of the sequence. When you are to find the general term or n term of the arithmetic sequence or the sequence given, we are to find the formula. So it says here now. You can also interpret it as finding the formula for the general term of the sequence. Okay? So we have now given the 6 and 8 terms. So again, let us have this way to solve for the unknown here. So that is, you have 1, 2, 3, 4, 5, 6. So we have this as negative 14. And then you have 7, 8, negative 20. And so on. Okay? So let us define first the common difference. And how are we going to get the common difference? So you can start by having these given terms here identified as your A1 and then it's your AN. Okay? So using now the formula, which is AN equals A1 plus 20N minus 1 times D. So AN is negative 20 equals A1 is negative 14 plus how many terms to be taken or to be considered here? We have 3 minus 1 times D. Okay? So this now negative 6 equals 2D. So what is then D? Divide both sides by 2. We have negative 3. Okay? Then let us now identify the original first term or A1. And of course, we're going to make use of the formula AN equals A1 plus the quantity N minus 1 times D. So still we'll be using the terms given here. Okay? So AN here is negative 20 equals A1 plus how many terms are to be considered here? 1, 2, 3, 4, 5, 6, 7, 8 minus 1. Then what about the common difference? It's negative 3. So that is now negative 20 equals A1 plus, we have 8 minus 1 is 7 times negative 3, we have plus negative 21. So therefore A1 now equals 20. Or 1 rather, no? So that A1 equals 1. So then let us now define the general term of the sequence. So using the formula again, an equals a1 plus 1en minus 1 times b. So an now is equal to a1. We have found already value a1 1 plus we have n minus 1 times b, which is negative 3. So we only supply terms, we only supply values for a1 and common difference when we want to find out the general term or the n term. So no values for a n and n, okay? So what is then a sub n? So 1 minus 3n plus 3, or we can also write this as 4 minus 3n, okay? So this is right.